This problem says a 30 kilogram object traveling at an initial speed of 10 meters per second gets acted on by forces that do 1,000 joules of work on it. What is the new speed of the object? So if I make a list of the knowns, I'll have a mass of 30 kilograms. I'll have a starting speed of 10 meters per second. So please note that knowing the mass and the starting speed is enough to calculate the starting kinetic energy. The question continues and tells me that I know the net work done on the object is 1,000 joules. Okay, so in these problems, it's going to be important that you're careful in knowing whether you have a force or a work. Right? Forces are in newtons. The work done by forces are in joules. So in this case, they give us joules, so I know it's an amount of work done. So this says find the new speed of the object. So V2 equals a question mark. And I am going to simply apply the new formula or principle for this week, which is the work kinetic energy principle, which has a formula of net work equals the change in kinetic energy, which the change in kinetic energy almost automatically gets replaced by K2 minus K1 when solving problems like these. So as my goal is to find out the final speed, it would be useful to isolate for the final kinetic energy. So that's simply adding K1 to both sides, and it will look like this. So the final kinetic energy will equal the starting kinetic energy plus the net work done on the object. At this point, I can calculate some of these things and fill in some numbers. I could also choose to keep everything in terms of variables and isolate for a final variable first. I think as I have a few problems I'd like to do, I may just alternate between those two styles so you see what they both look like. So for this one, I think I may just plug in numbers earlier on as we go. Okay, so K1, I'll do it off to the side. The starting kinetic energy will be half m v1 squared. And plugging in those values, it's a half times 30 times 10 squared. Half times 30 is 15. 10 squared is 100. So it's 15 times 100. And that's 1500. And that's in joules to 2 sig figs. So that's the starting kinetic energy. And I know my net work as well. It's in my list. It's 1,000 joules. So K2 equals 1,500 joules plus 1,000 joules. K2 equals 2,500 joules. So that's going to be the final kinetic energy. We're asked for the final speed. So I'm going to have to keep going here. I'm going to break K2 down into the formula for kinetic energy, which is half mv squared with the subscript of 2, because it's the final speed I'm dealing with now, equals 2,500. I know the mass is 30 kilograms, so I can plug that in. One half times 30 is 15. Divide both sides by 15. So what's that going to be? 15 into 25 is 1 time. Then I'm left with 10 carried down to 0, so that's 100 divided by 15. Goes in 6 times, leaving 10 again. So it's going to be repeated. 166.6 repeated. And then I square root that. Square root both sides. So that's going to be slightly under 13 because the square root of 169 is 13. But I'll just do it in the calculator here. So 12.9, rounded to two significant figures anyway, will just be 13 meters per second. So this is the first sample problem for the work energy principle. We're going to add more twists as we go along through these problems. You'll see what those look like.